Let's say that we wanted to find a moment about point A in three-dimensional space. Well, normally we'd use our typical formula, R cross F. The first thing to note about this is that this is not the same as F cross R. The order does matter in the cross product, so be careful about this. Now, we'll talk a little bit about the order again in a second, but let's continue on with the formulation of this. What we do when we have a cross product is we construct a 3x3 matrix. The first line of the matrix is all of the available spaces or directions that our final answer can be in. In this case, because we're just taking a regular cross product, the direction of our moment can be in any direction in three-dimensional space. So that means that the I, J, and K components are all fully available to us in our answer. That's why we put them here. The next thing is going to be our actual components of the cross product itself. Now, as I mentioned, the order matters. So because R comes before F in our cross product, we have to put all of our components of R first. The X, Y, and Z components of the R vector. Lastly, we'll fill in the X, Y, and Z components of our force vector. Now, if you don't believe me that the order matters, you can go ahead and try and flip these two and solve the cross product, and you'll find that it's going to be a different answer. Now, to do this properly, normally you take a bunch of determinants of this 3x3 matrix. But that can get pretty tricky, so here's an easier method. Just copy your matrix one more time to the right-hand side. Just like this. Now what we're going to do is we're going to take diagonal components of each one of our I, J, and K pieces. So what does that mean? Well, let's start with I. We'll take a diagonal from left to right like that. Now let's do the same with J and the same with K. So these are diagonals going from the left to the right. Now what we do is for everything that lies along a single diagonal, we multiply them together. So they look something like this. Ry times Fz times I is the first diagonal. The second diagonal is Rz Fx J. And the third diagonal is Rx Fy K. For this first set of diagonals, what we're going to do is we're going to put plus signs in front of all of these. They're all positive. Next, we're going to do 3 more diagonals. But these diagonals are going to go in the opposite direction. We're still going to do one each for I, J, and K, but they're going to start at any I, and they're going to go from right to left. Like that. And so we're going to do the same thing as we did before. We're going to multiply all the things along a single diagonal, like this. But for all of these ones, we're going to put minus signs. So the easiest way that I know to remember which ones have positive signs and which ones have negative signs is that we read English from left to right. So the natural direction to read these in left to right is the positive direction, while the backwards direction from right to left is all negative. So left to right is all positive and right to left is all negative. Now what we do with these is we combine all of the components. Because as you should know, I components can only come together with other I components. J components can only come together with other J components. And K components can only be added together with other K components. And what you end up with is something that looks like this. Ry fz minus rz fy, and let's pick this. That's the I component. Then we have a plus here, and our next piece is our j component, where we have a positive j and the negative j. Sorry for the different colors here. And lastly, we have our k components, which are rx, fy, and negative ry fx. And there you have the cross product.